Hello, tech design students. So we are back working on this. Lots of snow days. So I'm hoping that this recording will help you get on track with it. And here's where we're at. We have our drivetrain, and now it's time to start putting some motors on things. So in terms of motors, there's a couple things that we need to do. First off, we're going to have three wheels on each side and motors. Um, Right now, we're going to stick the motors in the back. Basically, we will have a gearbox, and then we'll have either belts or chains or something to be able to direct the power to the other wheels as well. So that's going to be what we're going to do. So the first thing is that we need to pick a gearbox, and Vex Robotics is a website where we get a lot of things from. Vex Pro. And in here, they have motions, gearboxes, and stuff like that. So in addition to Vex, there's also AndyMark, and they've got gearboxes as well. So with the gearboxes, we're going to pick the West Coast Products single speed gearbox. So that's what we're going to aim for. Now, to do this, a couple things. First and foremost, down at the bottom where we have the plus, we can go to applications and we can go to the App Store. So the App Store allows us to add apps for Onshape, and the one that we are looking for is called MKCAD, MKCAD. So this is the MKCAD app, and if you click it, you should be able to add it. Now I've already added it, so I only have the option to cancel it. But if you click add, you should be able to do it. You can see there's a lot of great reviews on it. It's a really well integrated app. So please do that. That will take you a few minutes. Once you have it done, you should see in your assembly the MKCAD logo will show up, and that's where you click it. Now, it's going to take a few moments to load up. So you might only see the favorites to begin with. Take some time. The first time you run it, it's going to take some time to load everything. So just wait, no problem at all. Now, here we've got all of our different options, and there's our gearboxes. So we click the drop down. And if you scroll down, you will see there is the West Coast Products single speed gearbox assembly configurable. So let's choose that. And if you click it, you get some options. So you have different motors and different gear ratios. Okay, and then how long it is. Now, to understand this, we need to take some time to work this out. So first off, Falcon 500 motors. I have this motor calculator, and I'll be posting all these links. And it's based on the JVN calculator. So there is the drivetrain. And in here, I can select Falcon 500. That's great. And what I'm going to do is I'm just going to leave these defaults, speed loss, drivetrain, gearboxes, two motors, the default 110 pounds of weight. That's pretty much good. 6-inch wheels. So anything that would be different there, we would need to change. So that is the key thing. Now, what I'm going to do, just going back here, is look at the ratio, 8:62. So I'm going to change this to 8:62 and then 1:1. So these are the gear ratios. And this is like an 8-tooth gear driving a 60-tooth gear. So that gives us some information. So based on that, we are able to get the overall gear ratio, which is 7.75 to 1, and we're able to figure out the speed. So the free speed is 21 feet per second. Now, realistically, that's if there was no friction at all. So once you adjust for friction, it's going to be about 17.24 feet per second. So that's pretty darn fast. And what you can do is you can look at if I change my motors. So if I use sim motors instead, that would slow it down to 14.4. And if I changed my gear ratio, so let's say I change that to 70, you can see I can slow it down etc., etc. So that's a pretty fast speed, but we'll just stick with the defaults for today. You can also see the current draw per motor. So if this was pushing against a wall, um, those motors would spike up to 74 amps. Um, and our fuses would kick them out. Okay, so I have my options. I'm going to go back to my plan. So I'm just going to accept those defaults for now. Obviously, you would play with the settings to get the speed that you want based on the game. Some games are wide open field where you want to be able to go really fast. Others, you want a lot of pushing power because there's going to be a lot of defense. Now, so here's my gearbox. So it's easiest, I find, to click the gearbox and then to be able to rotate it. So this triad manipulator, let me just undo that to explain. When I click on something in an assembly, I get the triad manipulator. And the triad manipulator is these three arrows. So my y-axis, my x-axis, and my z-axis. And basically, I have little arrows on them, which allows me to click the arrow and I can move it forward or backwards in that direction. Whoops, and I can type in the exact amount. I also have this, which is my rotate. So I can type that, and I find it's really useful to always type in a physical number. So there's 90 degrees. That is going to be where it goes. So what I'm going to do here is I've got this set up where I want it, and I'm going to use the fasten mate. Now this is where it gets pretty tricky. What I'm doing is you'll notice that I'm clicking the edge of the circular part right here. And look at the red, green, and blue. So that you want to be very careful to select that edge and not some other point so that it's centered. So there we go. And I'm going to go to this back one here, and I'm rotating my view and clicking. And just like that, I now have my gearbox mounted. So I can mount the gearbox here. Now, there's a couple things. Number one, I'm going to need some pulleys on here. And the beauty of this particular system, I'm just trying to show you here. So there's my bearing at the end. There's my pulley. What I can do is I can insert one right here, and I'm going to want probably another bearing right here to balance this out. So that's what I'm going to focus on. So just doing some double checking, make sure everything is good to go. Perfect. Now, later on, I'm going to need to modify some stuff. So I'm just going to hide my mates and hide my mate connectors. So with the gearbox, obviously, I can't just have a gearbox there. I'm going to need to find a way to fasten it and everything. And we're going to go over that momentarily. But let's start by just simply adding another one. And we have a couple of options. What I can do is just simply copy and paste the entire gearbox. And again, using my manipulator. Whoops, I want 180 degrees. I can turn it around, and I'm going to fasten it to the other side. So make sure, as I mentioned in class multiple times, you want to be very careful that you get the right mate connector. So clicking the edge and just taking your time. So there we go. We have gearboxes. We're going to need to add some other things in a moment, but we will get to that in a bit. Now, the plan is that we're going to have this gearbox. There's going to be a pulley right here, and that pulley is going to have a belt that goes right to here, and then there'll be another pulley which is going to go right to here. So that's the game plan. So here we need to mount the wheels and everything. Now, in this particular thing, what we'll do is we will mount a bearing directly into the frame here. Um, and we can do that. The machining required, you can use a mill, you can use the CNC router. We can do that. Now, it's really hard to get that positioning. You got to be very precise. It's mainly in the setup, which is really important. So what we're going to do is to make life easier for ourselves, we're going to only worry about that one hole in terms of the bearing. And so these other holes, what we're going to do is we're just going to simply mount a bearing block. And that allows us to kind of position things, have a little bit of slop, and we can get things organized. So ThriftyBot is a company where I really like their bearing blocks. These are their bearing blocks, and I'm just going to show you a picture of it. So basically, the idea is you have this piece of metal, and you can see the side profile here. So the bearing sits flush in the piece of metal, and then this goes over top of the square tubing. And you can see that's 2 inches. That's the same. It's just over 2 inches by like 0.01 or something. But that works really, really nicely. And then you put bolts in to hold the two pieces together. So you get two bearings. It works really, really well. The other thing is you'll notice that the center is dropped on one side. One side is lower than the other. So remember, our center wheel is dropped. So the side that's lower would be there, and then when we're doing the other, we flip it around and do the top. So let's use this Thrifty clamping block. Now, I don't know if they have it in StepCAD, but I want to show you a different skill, so I'm going to show you how to do that. On the Thrifty Block website, they have something called a StepCAD model. So you can see I have downloaded that, and what I'm going to do now is I am going to import that. So you just need to click on it and download it. And then in here, I can do my little plus sign, click import, and then I can just find the file. And Thrifty Camping Block. There we go. So I get a couple of options. I'm just going to click OK. So I've got a lot of different options there. Now, that's going to take a few moments, and once it's done, I should be able to open it up, and there we go. There's my clamping block. So because it's a step file, I should go in and edit the material. And if you look at that drawing, 6061 aluminum. So I am going to set that to aluminum and find the 6061. There it is. So there's my bearing block. And what I'm going to do is with my assembly, I'm going to insert my bearing block. Now, first things first, let's rotate it. And what I want to do is look at it. You can see this side, minimum distance. So this side is the lower, so that's going to be for the center. So what I will do is I'm going to do a fasten mate. And actually, cancel that. Let's add our bearings. So let's go back to good old MKCAD. And MKCAD, you can see that there's bearings. And we'll use the configurable bearings because that's nice and easy. So if you click the drop down, you've got a lot of options. We are looking for 1/2 inch thunder hex by 1 to 1/8 OD flanged. So 1/2 inch thunder hex by 1 to 1/8 OD is outer diameter flanged. So let's insert that. There it is. We'll just hide that. So the fasten mate, what we'll do is we will just click that and insert it. So it should, oops, that does not work. So open that back up and just flip it if it doesn't. There you go. So there's my bearing block, and now I can fasten it. And zoom in, and remember, there we go. So there's my bearing block, and basically we're going to have another one on the other side. So I select both, copy, paste, and I'm going to rotate that 180 degrees. Got the center. And there we go. And because I copied and pasted something that was already fastened, everything fastens. So that's perfect. Now, with this particular bearing block, you can see there's 4 holes. And one hole is bigger than the other. And if we look at our diagram, so the bigger hole is a through hole, and the smaller hole is a threaded hole. So the threaded hole is the back of where we're going to put it. So that's going to be really useful. And you can see on here that it takes 4 10x3 1.5 inch long button head bolts. So what we're going to do is we are going to select the big holes. So zoom in, get that big hole right there. I did a bad job of that. So there's the big holes, and then on the on the other side, those. Okay, so I'm going to insert standard content, ANSI inch, bolts and screws. Now, socket head, we want to change that because, oh no, socket head screws is correct, but it's the socket button head cap screw. That's what we want to pick. So, and this, if I look at the thing, it's 10.1032 and 1.5 inches. Okay, so if I click insert, it should put it all in. And if you ran into a problem with that, just hit cancel, insert, and the key thing is to have those circles selected before you click the insert. That makes all the difference in the world. So right click that and hide all make connectors. So couple options here. You can see basically just the friction of this will actually hold this in place. You do have some options though. You could drill, once you have everything tight, you could then use one of these holes and drill a bolt through to lock it in place. So it's pretty handy that way. Now, what we have here is we have what we're going to do is we're going to select all of that. So the bearing block, boom, 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 boom. And we're going to right click and we are going to move that to a new subassembly. And that's going to be called assembly 2. So let's just go into assembly 2. So there's assembly 2. Now we're going to right click on the tab and rename it. And what we'll do is we'll call it bearing block. And I like numbering things because I find it much easier to keep track of. So this is going to be my my number like that, and then -02. So it's a subassembly of that. The reason it's going to be -02 is I'm going to go into assembly. Actually, let's rename that to 03. I better start cleaning up everything. There's assembly 1. Right click, rename that. Same thing. So use the number that you created for your robot. So it should be your initials, LBD for learning by design, A00, and then 01. And I like putting the name after the subassembly number so it's easy for me to find things. So we've done the gusset assembly, but we never numbered it. So let's do that. So we have 3 subassemblies now. Okay, back to the drivetrain. And if you have trouble manipulating, remember the tab manager, you can go in. As things fill up, you can see we can filter by just assemblies. So it starts getting easier to find things by doing that. Okay, so now that we have that subassembly, what we're going to do is we are going to insert, oops, not what I wanted. Yeah, it is. Insert current document assembly, and we will insert another bearing block. And while we're at it, we're going to insert 2 more. 1, 2. And that's the whole point with the subassembly, is that we can easily switch things around. So this bearing block right here, we'll just zoom in and get that mate connector that's at the center of that inside and zoom in there. And don't worry, you'll notice that it didn't bring everything. Once you hit the green check mark, and you'll notice that I'm using this small, or no, I'm going to do that. Oh, everything didn't come together. So let's go back to the bearing. Okay, so in here you can see, yep. All right, so what I'm going to do, first things first, just undo that. The first bearing block, I'm just going to fix that in place. So now I can drag the second bearing block. And this one, what I'm going to do is I'm going to fasten. And I'm going to fasten that point to that point. And green check mark, and now everything's in place. So if I go back to my drivetrain, you should see it moved everything together. So that's all locked together. Perfect. Okay, now these 2 bearing blocks are going to be for the front. And what I need to do is I'm going to select both of them. So I'm just over here in my instances, I can select both. And now I can use my triad manipulator and just rotate that 180 degrees. So it looks the same, but if you notice, the bearing is now higher up, which is what I want. Okay, so another fasten mate. I'm going to select that. Going to scroll in there. Now, you'll notice I've got 2 little options here. This one and this one. So this one is really handy because I can click the green check mark and it leaves me in the fasten mate, because that means that I probably want to do another. So there's little tricks like that that really speed everything up. So I'm going to just do the same thing. And there we go. So I now have my bearing blocks. I have my gearboxes. Um, there's still a lot to do. I need to obviously add my pulleys and my wheels and things. Um, but overall, I think I'm doing pretty well. And I need to obviously fasten the gearboxes. I'm going to stop here. So some of those steps we'll do in the next round. And there you go.